Hello, and welcome to this Vivado Quick Take video tutorial focusing on using memory controller IP with UltraScale devices. The agenda for this tutorial will start off by introducing the Vivado Native Memory Controller IP, or MIG. We'll walk through the steps to configure the IP using the new Vivado Wizard, and then the majority of the demonstration will focus on the I/O planning phase for the memory interface. We'll walk through how you can select the banks for the various byte groups within the memory interface and how to do specific pin placement adjustments if need be. We'll talk about using multiple memory controllers, and then we'll discuss the roadmap for I/O planning for MIG IP. Before we introduce the UltraScale MIG IP, let's review what we had in 7 Series. When you configured a MIG IP from the catalog, the old core generator style MIG configuration wizard appeared. The core generator tool is from the legacy IDS solution, and the MIG IP was the last IP to use it through the 2014.2 release. Starting in 2014.3, all MIG will be configured using the Vivado native configuration wizard. For 7 Series, the customization wizard walked you through the various panes to select the type of interface and device you wish to target, and then all the various parameters to allow you to configure your memory interface. There was a pane for selecting the I/O banks to assign the various byte groups associated with the memory interface. This was the only way available to do your I/O assignments for your memory interface within the interactive environment. No specific pin manipulation was available. You would then select your clock pins and where you'd like those to be assigned. A summary of the memory interface configuration was presented, as well as a license agreement. There's also a pointer to the printed circuit board design guide for MIG designs, as well as some design notes and descriptions of the key enhancements over the various releases for this specific IP. When the output products for the IP were generated, you'll see the out-of-context synthesis run for the IP, and if you look at the sources, you'll see the resulting DCP file that was generated, as well as all the source files for doing simulation and implementation. The constraint file contains all of the IOs that were assigned automatically through the bank selection we made within the configuration wizard. With this particular methodology, all of the physical constraints for the IOs are resident within the IP. So when that IP is used, those physical constraints that were assigned initially follow that IP. Now let's take a look at the UltraScale MIG IP flow. Notice that when MIG IP is now configured from the catalog, a Vivado native configuration wizard appears. There's some options at the top here to enter a name for the IP, as well as an IP location. This is a location on disk to store your IP for this project or for other projects. There's access to all the documentation and information about the IP, as well as an advanced tab that we'll discuss in a moment. I'll click on the Add button to select the type of IP I wish to configure. For this example, I'll select DDR3. The various panes allow me to configure the IP, much like 7 Series. Here I'll select a data width of 16. I then get to the bank selection pane, which is, again, very similar to what you had in 7 Series, where you can assign the various byte groups to the different banks in the design. Notice that when I'm moving this interface, when I have an illegal condition, the byte groups are displayed in red. So I'll select this whole interface and move it into bank 45. The next pane provides an option to invoke the MIG I/O planner. As you can see in the verbiage here, the MIG I/O planner should only be used for doing fine-tuning of the IOs once the initial bank selection has been made for the byte groups. The MIG I/O planner is a slimmed-down version of the Vivado pin planning environment that will allow you to make minor adjustments to the pin assignments should that be needed for any particular reason during printed circuit board layout. There's a set of MIG-specific DRC rules that can be checked, and if you make any modifications, there's an Apply Constraints button to write those back to the IP. The next pane provides access to the MIG design checklist. This is similar to the ultra-fast design methodology checklist in that it presents a series of questions in each of the various design stages with courses of action and links to various information about those questions. It's a good idea if configuring a memory interface for the first time to walk through this checklist to ensure you've covered everything in your design and design process. A final summary sheet is presented. When I click on the Advanced tab, notice that each pane of the wizard now has a specific tab that I can jump directly to. This is convenient when you know exactly where you need to go within the configuration wizard. Notice over on the left, based on my configuration settings, I get a utilization estimate of the resources that this particular IP will consume in the FPGA. When I select the IP symbol tab, notice the symbol for the MIG IP is displayed. And I can turn off the display for the non-use ports, and clicking OK customizes the IP and prompts you to generate the output products. Here again, the out-of-context synthesis run is created for the IP, and all the various output products are created. And just like 7 series, the physical constraints for the IP are contained within the IP constraint file, and they are resident with the IP in any design they're used. For example, when I open up the example design and run synthesis, then I'll open up the synthesized design. Notice those IOs are already placed. You can analyze the placement of the various byte groups and perform pin planning for the rest of the design while viewing them. These are essentially fixed resources though. Any manipulation to the MIG-related IOs needs to be done in the MIG customization wizard and the MIG IO planner, not within the main Vivado IO planner. Notice what happens when I try to move a port. When I run DRC, it gives me a detailed description of that fact, that all the IO manipulations need to be done within the MIG customization wizard. Moving the port to this pin also created other problems with the VREF, so we'll move it back. And notice now the critical warning is gone. Let's now walk through the process for modifying MIG IO ports. In order to make MIG IO adjustments, you need to recustomize the MIG IP. Here I'll use the Advanced tab and cycle directly to the Pin Planning tab and open up the IO planner. In this example, let's say our printed circuit board designer really wanted to swap 2 pins around for better routability. So unfortunately, the MIG IO planner doesn't have the swap command yet, so I'll move these pins around to effectively swap their locations. And notice these are address bit 0 and 9 with 0 on the right side here. And when I run the MIG DRCs, it says no violations found. I'll now elect to apply these constraints to write them back to the IP. And since I've modified the IP, I need to regenerate the output products. And in doing so, that's put my top-level synthesis design out of date, so I'll resynthesize and open up the synthesized design. And you'll see when we look at the 2 pins that they are in fact swapped with the address 0 on the outside here on the right. And you should rerun the DRCs within the synthesized design to ensure that the general I/O guidelines are adhered to within the I/O planner. I do get a warning saying that my config BVS and config voltage properties are not set, which I should do, but there are no I/O related DRCs, so we're good to go. That is the process for configuring and maintaining the MIG IOs. In addition to the I/O constraints that are contained inside the MIG IP, there's also a P-block constraint. This is a temporary constraint that we've added to the UltraScale MIG IP to improve timing. And just like the MIG IO constraints, it is resident within the IP, and it follows it around to the banks that the IP is assigned to. We will be trying to get rid of this P-block constraint in future revisions of the IP. Now let's talk about designs with multiple memory controllers. Here I've opened up an example design with 4. Notice that each memory controller has to be a separate and unique IP added to the project. Care must be taken when selecting the banks to assign the byte groups to for each IP to ensure they end up in separate banks. In this case, I wish to share a bank. Notice in MIG0 here I've elected to use the bottom 2 byte groups of bank 45. And when I open up the MIG1 instantiation, I use the other 2. This is a means for sharing the I/O banks across multiple memory controllers. And notice when the design is implemented, each memory controller is contained within the P block assigned, and the area where the P blocks overlap is shared nicely between the two memory controllers. One caveat when sharing banks between multiple controllers is that you do need to add a top-level XDC constraint file to avoid the potential conflict of the clock routing tracks caused by the buffed GCEs. Answer records 6105 and 6106 address this issue. So that's how you can handle multiple memory controllers in Vivado 2014.3. So in summary, beginning in 2014.3, all UltraScale MIG IP is native to Vivado and uses the Vivado customization environment. This should provide faster load times for IP customization. The IP symbol and utilization statistics for your particular configuration are displayed, as well as links to documentation, websites, and answer records. It also enables remote IP source location for easier access for other projects or revision control systems. And we've enabled the MIG I/O planner for making small edits to the I/O port assignments. Remember, with this methodology, all MIG I/O planning is performed during IP configuration. This ties the I/Os to the IP directly. Any downstream edits in the top-level design to the MIG I/Os result in DRC critical warnings. Any I/O modifications to the MIG IP require regeneration of the output products. And finally, Xilinx has provided the MIG design checklist to help you validate your MIG design and design process. Now let's talk about the roadmap. We do recognize that there are some limitations in this flow, and we have plans to rectify it. We'd like to separate the memory controller customization from the I/O planning of the memory controller. This makes the MIG IP more portable to other designs and devices and wouldn't require output product regeneration for I/O changes. You'd also be able to perform your MIG IP I/O planning along with the rest of the design by providing interactive placement with a global view of all the design ports and the design. It's much easier to do I/O assignment when you can visualize the data flow through the design for more intelligent decisions. This should also facilitate easier I/O bank assignment when sharing banks amongst multiple controllers. You'll also be able to manage all of your I/O related physical constraints at the top level in a particular constraint file. We are looking to roll this out sometime in 2015, so stay tuned for that. And rest assured, we will be providing seamless migration from the IP-based constraints used today to top-level constraints. Thank you very much for your time.